In the last topic, we discussed data storage and Amazon S3. Now it's time to discuss how data is organized in this service. Amazon S3 is an amazing object container. Now, like any bucket, you can put content into it neatly and orderly, or you can just chuck it into the bucket.
Yeah.
No matter how the data gets in there, once it's there, you need a way to organize it in a meaningful way so that you can find it when you need it.
And this is where data lakes come in. A data lake is an architectural concept that helps you manage multiple data types from multiple sources, both structured and unstructured, through a single set of tools. All right, let's break that all down. A data lake takes Amazon S3 buckets and organizes them by categorizing the data inside the buckets. It doesn't matter how the data got there or even what kind it is. You can store both structured and unstructured data effectively in an Amazon S3 data lake. AWS offers a set of tools to manage the entire data lake without treating each bucket as separate, unassociated objects.
Now, many businesses end up grouping data together in numerous storage locations called silos. These silos are often dedicated to a single department. They are rarely managed and maintained by the same team, which can be problematic. Inconsistencies in the way data was written, collected, aggregated, or filtered can cause problems when it is compared or combined in the processing and analysis phase. For example, one team may use an address field to store both the street number and the street name, while another team may use separate fields for the street number and the street name. Now, on their own, this is totally fine, but when these data sets are combined, now there's an inconsistency in the way the address is stored, and it will make analysis very difficult. But by using data lakes, you can break down these data silos and bring the data into a single central repository that is managed by a single team. That gives you a single consistent source of truth. These data inconsistencies with the addresses will no longer be a concern of the data storage system. Now, because data can be stored in its raw format, you don't need to convert it, aggregate it, or filter it before you store it. Instead, you can leave all that pre-processing to the system that processes it, rather than the system that stores it.
So, in other words, you don't have to transform the data to make it usable.
Right.
You keep the data in its original form, however it got there, however it was written. And when you're talking potentially exabytes of data, you can't afford to pre-process this data in every conceivable way that it might need to be presented in a useful state. Let's talk about having a single source of truth. When we talk about truth in relation to data, we mean the trustworthiness of the data. Is it what it should be? Has it ever been altered? And can we validate the chain of custody? When creating a single source of truth, we're creating a data set, which in this case is the data lake. It can be used for all processing and analytics. And the bonus is that we know it to be consistent and reliable. It's trustworthy.
So, to bring it all together, we know that businesses need to easily access and analyze data in a wide variety of ways, using the tools and frameworks of their choice. Remember the second principle we spoke about in the last topic. Moving data between storage and processing is costly. Amazon S3 data lakes provide a single storage backbone for a solution meeting these requirements and tools for analyzing the data without requiring movement. In the next topic, we're going to discuss the nature of data storage within data processing applications.